Hello, everyone. I hope everyone is having a blessed day or night in my case. And so here today, I just want to show you guys a practical example of using NGINX as a reverse proxy to a Node.js server in this case. All right. And I actually have a video which will be linked down below, which shows a system design or a higher overview of this. All right. Now, in this video, I'm actually going to show you the practical way and the way that you can get your hands dirty and actually get started on this as well. All right. So here we have two servers. This is my NGINX server, and then this is my Node.js server. And a quick overview on how this works. And for that, I need to go into my drive, and here it is. All right. So quick overview of how this works is essentially and I'm gonna want to use Screen Brush. So let me just open that up. Sorry. So essentially, this NGINX server is going to be between the front end and back end. So whenever the front end decides to make a request, it's not going to go to the Node.js backend first immediately. It'll go to NGINX server first. This allows the NGINX server enough time to process the request before it is actually sent on to the Node.js backend server. Now, same thing applies when this backend server, right, it provides us with a response. It will first go to the NGINX server, right? The NGINX server will do something, pre-process it or whatever, and then it is sent to the front end. All right. Now, you might be asking yourself, why would we add this middleman? Because that's going to add more complexity. And then eventually, as our application scales, we have another whole server that we have to worry about scaling, right? And there's many reasons for this. The two main reasons why I have chosen it is for caching. All right, this way your API stays highly available because you're not keep making repetitive API requests for data that's highly available, and also rate limiting, which is what I'm going to show you in this video. All right. And essentially what rate limiting does is it basically prevents a spam in our API by limiting the amount of times a request is allowed to be sent on a specific IP. And we'll see all of that happening with NGINX because NGINX takes care of it. They have something called a directive, and we'll learn all about this later on, but they have a special directive for rate limiting. All right. So now that we've gotten a basic overview of how everything works, let's get our hands dirty. So I have spinned up a Linux server here, which I've SSH'd into, okay? I'm just gonna go ahead and clear this out. And that's how we're running these two servers, all right? So they're both on the same IP address, but on just different ports, right? This one is on 3001, and then this one's on 8080, all right? And by the way, for anyone who's curious, it is just a simple a VM which I'm running this server on, right? It's just a Linux Ubuntu server. All right, you could do it on Mac OS itself, but I decided to be extra and just have it in my own server. That doesn't really matter. Anyways, going back here, all right, let's look at my nginx.configuration file. So this is how we can actually configure our nginx server so that I can do different things. All right. So in this case, we've got some very nice coloring as well with Vim. But this is just read only. If you notice over here, it says read only, and that's because we didn't give it sudo permissions. And that's what I intended anyways, because I just want to show you guys. So here we have different blocks, all right? And this is an example of a block, all right? And I'm just going to show you guys over here. This is an example of blocks. It's in the events, all right? And essentially what a block is, it's a collection of directives. Directives are these, all right? They are basically a key value pair in which you are basically running commands, all right? Think of them as running like a command on your command line. But these commands actually configure an NGINX server, all right? So in the case of events, you only have one directive, but you can have many because again, events block or a block is just a collection of directives. In this case, we have an HTTP block which holds a child block of server. In the case of if you deploy it, you probably want to use HTTPS because your server might be using that SSL encryption. And for that, you need to also configure that. And I'll leave a video below on how you can do that and all that stuff. But yeah, if you want to use HTTPS, you need to make sure that you configure SSL configuration. All right. Okay. Anyways, within the server, you will see that we're listening on port 8080 through these two commands or directives. So that's how we are able to actually run our NGINX server on 8080 within the IP, because the IP is the Linux server actually. And then within location, we are just serving an index.html file, which I've actually gotten from the from this route over here. I created it myself. All right. So I'm just gonna go ahead and quit out. And so now that we understand a little bit more of how this works, let's go ahead and create the reverse proxy and this architecture that I was talking about, right? So to do that, I actually have the code on GitHub just over here. All right, it's right over here. So I'm gonna go ahead and just copy this, and we'll go ahead and learn how this works. Okay, so we're gonna go ahead and do sudo this time, vim nginx.conf. There we go. I'm gonna do I to insert. Oh wait, actually, sorry, hold on. I'm just gonna do this instead. I'm gonna delete all of it. There we go, and then I'm just gonna copy it. There we go. Perfect. I'm just gonna cancel out of insert mode. I'm just gonna write it. Okay, I'm not gonna quit. I'm gonna quit later on because I just want to show you guys. So WQ within Vim allows you to quit as well as write your code. In this case, I just want to write it. I don't want to quit because I want to show you guys. But anyways, in this case, we have our events directive as first. That's default, right? We need to have that event block with our workers connection directive. That just lets us know how much simultaneous connections we can do per thread, right? Thread is within like the CPU. Anyways, now this is where a lot of things change. In the HTTP block, we actually have a directive, and this allows us to create a zone, all right, a zone in which we can save our IP in the IP of a specific user, all right, and we're limiting it to 10 megabytes. This could change, but 10 megabytes will allow you to store 160,000 IP address. All right, so I think that's a lot, and it should be good for much of your app scales, but obviously just make this larger if your server allows for it, right? Okay, so essentially what this is doing is it is allowing us to store different IP address within the NGINX server, because that's how the NGINX server will be able to get an IP address and figure out, okay, is this IP address met its limit, or is it okay to send that request to the Node.js backend server? So we're essentially saving the IP address with this directive while putting a quota to it. So then the NGINX server knows how many requests is it okay to accept before it starts rejecting requests. In this case, it's one rate per minute, which is very, very low, but it's just to show you guys, right? I'm going to change it within production level, but this is how production level code would look like. Anyways, within the server block now, again, we're listening on port 8080. Now we actually added another directive, and this is just called error_page 503. So basically what happens is whenever we have a lot of requests, right, it uses the 503 error code. So we're essentially serving a special route whenever this 503 code is returned, all right? And this is what we're actually looking at next. So location, if I didn't mention earlier, allows you to specify different routes within your NGINX server. In this case, we're specifying a special route called /service unavailable, in which we're returning some JSON, all right? And we're just setting the default type to application/JSON as well, all right? Completely optional, but again, I want to make sure everything is done very, very to the T. Then for our root location, all right, which is / our default, we are going to be adding this limit_rec. So this is how we're actually going to be enforcing this the rate limiter, right? Because this, what it's doing is it's actually just going to be saving your remote address, right? Or your IP address through here, right? It's just gonna be saving it on the server with the rate limit. But this is actually enforcing a rate limiter using the information that it's saved from before. Because again, everything is run one by one, right? So it's going to first save it within the server, and then when the user goes for location, the route, right, which has the root, right, this slash, sorry, is going to go ahead and reference back to that IP address that it's saved, and then go ahead and rate limit based off of that, like do its logic based off of that. In this case, it would see if the rate limit has exceeded based on what we have specified here. All right. Now, a very important thing to note is this actually changes the behavior a little bit. Okay, burst, and what that means is that, so pretend you send a request. All right. Now, what's going to happen is that if you send a request, in this case, I have one request per minute, and you reach that quota, if multiple requests are sent after that, like many requests immediately after that quota is reached, in this case, 1 rate per minute, then we will allow those requests to go through until a certain limit, in this case, 20 requests. So let's say I press the refresh button. All right. I've pressed it. Okay. Now it should stop, right? The service should become unavailable because I've reached my quota for that minute. But let's say immediately after I press that refresh button, I keep hitting refresh. It will still allow me to send those requests up till 20 requests. All right. And the node delay just ensures that there's no delay between those requests, because by default, what it will do is it will allow these requests to go, but on a delayed manner. All right. With no delay, we're just going to immediately send those requests out. All right. So this just allows us a better user experience if we have a high amount of traffic, right? So yeah, that's why I kept it. And that's the whole reasoning behind it. All right. So now you know. Now, proxy underscore pass, this is the important part. This is how we can actually go ahead and send the request that we got from the front end to the back end. That single code will allow us to send that request that we got from the front end to the NGINX to the back end within Node.js, right? This endpoint being the Node.js server. Okay. All right. So cool. Now that we understand how everything works, right? Again, proxy underscore pass will just allow us to send the request that we got from front end to the NGINX server to the back end actually, and then get a response back, and then send that response back to the server. So basically, it is what is creating that reverse proxy that we talked about, or that middleman, right? Now though, actually, funnily enough, I have to actually change this to 3. First of all, it should be 192 point. I'm just gonna go ahead and take this. Yeah, sorry, I just had to change the address because it's hosted on this now. All right, so yeah, I think everything should work perfectly. So if I just go ahead and save this and quit, if I just do a cat, this way I can just see if I can just see the content of a file within Linux or a Unix-based system. You can see all my changes are saved, and I explained everything, right, to you guys. Let's go ahead and try this out. So I'm going to do ngix.t. This will just test everything to make sure everything works. All right. Okay, so the reason why it failed was because there was a permission denied, and that's because I didn't use sudo. So let me just do that again with sudo. There you go. As you can see, the test is successful. So I'm just gonna move on and sudo NGINX.s reload. What this is doing is it's signaling what that -s means. So it's signaling the NGINX server to reload. Okay. Now if I go back here, as you can see, we're giving the same request because it's forwarding my request to the Node.js server, right? This Chrome browser or whatever is the front end, right? And we're requesting it to the NGINX server, which is 8080, and that is actually forwarding it to the Node.js server. So in actuality, we are requesting it to the NGINX server, but it's porting it to the Node.js server, so we're actually getting what the Node.js server wants. And now, as you can see, I get that service is temporarily unavailable after a while, and that was because I configured the burst option. If I don't have that, it will immediately stop after one request, but I want to keep it for good user experience. But as you can see now, the service is temporarily unavailable because there's too many requests hit, and then after the minute goes by, I can restart it. All right, and of course, within the configurations, right? So I'm just going to use cat to do it. Within the configurations, I would definitely recommend changing the rate because the rate is very, very low right now, right? One request per minute does seem a little bit unrealistic. So I'll probably allow more requests and probably by the seconds, not the minute. But this was just so that I can show you for demonstration purposes. Additionally, another thing that I would do is, again, make sure that you change your proxy path to your Node.js server, or else it'll give you this following error. All right. Whoops. Wrong file. Okay. So pretend I do like 3002 instead, right? Let's save that. And then I'm just going to do nginx.t just to make sure everything's good. I don't want to like crash the server. Okay, now let me go back. You'll see you'll get this error over here, which just says 502 bad gateway, and this is because it cannot find that server which you want to forward the request to, right? Because again, what's essentially happening is the NGINX server is not handling with the request itself. What it's doing is managing it, right, and changing it and whatever it needs to do to the request, but it's not handling it itself, right? It is the only sole job of it is to take the request, do something with it, in this case rate limit and then cache, maybe we'll look into that later on, and then forward it to the backend, in this case our Node.js server, get a request back, and then send that over back to the front end. All right. But now what's happening is, we're sending our request to the NGINX server, and then the NGINX server is like, okay, I got it. Let me go ahead and send it to the backend on port 3002. But the problem is there is no backend on port 3002, so it's not going to get a response back or nothing. So then what happens is like, oh shoot, I don't have a server to go to. So it's just from the NGINX server, it's going to be like, oh, 502 bad gateway, because I can't really find this server. So without all the app, essentially make sure that the proxy path has the correct endpoint for your backend server, especially in production. Okay, so I'm gonna go back. I'm gonna go ahead and change this so that it doesn't have that the wrong server. Let's go ahead and reload that. And now, as you can see, we get that hello world, and then there's also a /cool route as well. This is the cool route, and this all works. If I just go here, and I'm just gonna go ahead and cancel out for now. But if I do cat index.js, you'll see that I do have indeed both of those routes over here. All right. So yeah, again, you don't have to go all fancy like me and like spin up a VM, which I did, and then SSH so that you can use your own terminals. Right? You don't need to do all that. You don't need a Linux server. I just decided to use a Linux server because that's how I just wanted some more practice with my Linux, skills and all. But this would all work on Mac OS and I believe Windows, but it's just a little bit more of a pain on Windows. So I'd recommend just using WSL. But yeah, there you go. So that is how we completed a reverse proxy. And as you can see, the rate limiting we also were able to implement, which happens over here in the NGINX server. So in the case of a bad request or too many requests, right, it won't even alert the backend. As far as the backend is concerned, the requests that I've sent with the 503, like the 503 errors, they don't exist because the NGINX server will just return this error, right? Because this is again in the NGINX server, right? We configured this within the NGINX server, which we can see over here. If I look at the NGINX config file, right, through here, through here, right? So yeah, that is it from me. I hope you guys enjoyed this video and got some informative, guidance from it. Again, it was not really like a tutorial. It's more of like me showing off and like showing my skills. But yeah, I still hope you enjoyed it and got some value from it. Hemet out.